All right, let's jump straight into this explainer. We're looking at a highly technical blueprint for using AI agents to safely optimize a completely bloated Plex media library. Look, if you run a home lab, you already know the struggle. Storage space is not cheap, and our digital collections, yeah, they literally always expand to eat up every single available gigabyte. But today, we're unpacking a fascinating workflow from the XDA community that completely flips the script on data hoarding. Check this out. Just by pointing a terminal-based AI at a media directory, one user actually reclaimed a staggering 8 terabytes of wasted storage. 8 terabytes. Think about that for a second. That's an entire $200 high-capacity hard drive instantly freed up. And the crazy part, they didn't even delete any actual media they wanted to keep. So how is that even possible? To understand how this magic trick was done safely, we're going to walk through 5 key areas. First, the accidental storage hoarder. Second, why AI agents are totally different. Third, the safety-first blueprint. Fourth, the expert cleanup checklist. And finally, a really crucial automation warning. So, Chapter 1, the accidental storage hoarder and the silent cost of all this automation we love. You know how it goes. Once you get a media server humming along, adding content is basically clockwork. But that amazing convenience, it masks a constantly growing problem. From the front end, your library looks pristine. Everything has a nice poster. But behind the scenes on your drives, you're just accumulating invisible junk. We're talking multiple copies of the exact same movie from automated release upgrades, totally abandoned torrent files, sample videos, and just massive uncompressed video formats. Think about it. When your system automatically grabs a better release, did it actually delete the old one cleanly? A lot of times, the answer is no. Without you even realizing it, your beautiful automated setup has probably hoarded hundreds of gigabytes, maybe even terabytes of pure, unadulterated digital clutter. Moving into Chapter 2, why AI agents differ, and how they escape fixed rules. Normally, when we hit a storage wall, we reach for purpose-built tools, right? Things like Unmanic, and don't get me wrong, those are fantastic, but they're rigid. They only follow the exact fixed rules you punch into a user interface. Terminal-based AI agents, though, like Claude Code, Grok, or Codex, they operate dynamically right inside your file system via SSH or a NAS mount. They can actually look at the broader picture, reason about your specific folder structures, and make dynamic, context-aware decisions based on exactly what's sitting in your library. And this is absolute key. Everything happens locally. The AI isn't sucking up your media files and sending them to the cloud. Instead, it's acting like a really smart conductor for the powerful open-source CLI tools that are probably already installed on your machine. It orchestrates FFprobe to scan metadata, directs FFmpeg to transcode bloated files, and runs hash checks to spot exact byte-for-byte duplicates. It's using the tools we already know and love, just infinitely faster. Which brings us to Chapter 3, the safety-first blueprint, because we need zero data loss here. Look, I get it. Handing over the keys to your file system to an AI is honestly terrifying. If you just type, "clean up my library," and hit enter, you are practically begging for disaster. So to guarantee zero data loss, this whole workflow is structured around a strict 3-step safety shield. We absolutely cannot leave anything open to interpretation when an agent has the potential power to delete files. Step 1 is explicitly forcing a read-only audit. You command the AI to look, but absolutely do not touch. It uses its reasoning to separate the obvious junk from the files that actually need a human decision. Like having 2 copies of the same movie, but one's the director's cut. The AI then spits out a highly detailed Markdown or CSV report showing exactly what it found and the potential storage recovery. You can just sip your morning coffee, review the list, and rest easy knowing not a single byte has been deleted yet. Then we hit Step 2, the quarantine phase. Instead of firing off a destructive delete command, the script simply shifts all that approved waste into a temporary holding pen, a quarantine folder. This is brilliant because it lets you fire up Plex, do a library scan, and verify all your posters and metadata are still perfectly intact, basically making sure your family won't yell at you for breaking the server on movie night before you actually empty the trash. Finally, Step 3 handles the oversized files. The AI identifies ridiculously bloated H.264 media and automatically generates the exact FFmpeg commands needed to convert them into highly compressed H.265 files. The space savings here? Absolutely massive. These aren't necessarily junk files, they're just horribly unoptimized, and the AI fixes that for you. All right, Chapter 4, the expert cleanup checklist. This is where we get into some community power users' secrets. Because when you crowdsource AI prompts from serious power users, you get absolute gold. Take XDA user ELI, for example. He pointed out that blindly running hashes across an entire massive library will thrash your drives and literally take days. So instead, you instruct the AI to group files by size first. Then it only runs those intensive byte-for-byte hashes on the tiny fraction of files that happen to share the exact same file size. It's such a simple but genius optimization. Another huge aha moment, you have to explicitly instruct the agent to detect hard links. If your automated setup relies on hard links to keep seeding torrents while also displaying the media in Plex, a naive AI is just going to see two massive files and think, duplicate. You have to prompt it to check the inodes, the underlying storage addresses on the drive, so it doesn't give you false hope by promising phantom storage savings from zero-space files. That is absolutely crucial for safely doing this on a media server. Also, you really want to avoid using flat file size limits. If you just say, delete anything over 20 gigs, say goodbye to your legitimate, pristine 4K remuxes. Instead, prompt the AI to look for bitrate for resolution outliers. Basically, tell it to hunt down a 1080p file that has a bitrate completely out of proportion for its runtime. That's how it accurately targets those bloated, poorly encoded rips hiding in the shadows, while leaving your high-quality stuff completely alone. The expert prompt also acts like a vacuum for all that other invisible junk. We're talking orphaned subtitle sidecars, corrupted incomplete downloads that got stuck, files with zero duration because a download totally failed, and all those empty folders just cluttering up your directory tree. The AI can sweep up the whole shebang in a matter of seconds. Which brings us to our final chapter, the automation warning. Time for a reality check. Because as incredibly cool as this all sounds, the stakes here are very real. Community member Matthews brings us right back down to earth with a pretty sobering warning about fully automating recursive delete commands. And honestly, he hits the nail on the head. An AI hallucinating while it has root delete permissions on your primary media directory, yeah, that is the stuff of absolute nightmares. The underlying technology we have right now is insanely powerful, for sure. But human oversight and strict quarantine workflows are absolutely non-negotiable. You are leveraging the AI to parse through data, read metadata, and compile massive reports. You are not using it to unilaterally pull the trigger. You have to remain the final line of defense to protect your data, always. So, after walking through this whole blueprint, the big question is, are you ready to trust a terminal AI agent with your home lab's file system? Or are you going to stick to those traditional fixed-rule tools? Honestly, reclaiming terabytes of space with just a few context-aware prompts is a massive paradigm shift. It really makes you wonder, what else could these local AI agents optimize on our servers if we just let them? Thanks so much for diving into this explainer with us, and we'll catch you in the next one.